Bullpup rifles keep winning the same argument on paper: move the action behind the trigger, keep the barrel, lose the length. For more than 160 years, designers have called that geometry the future. The strange part is how often the future sent the rifle back. The first known example appeared around 1860, long before armored vehicles made compact weapons fashionable. That fact changes the story. The bullpup was never born as a modern solution. It was an old spatial idea waiting for technology and armies to catch up. In a conventional rifle, the action and magazine sit ahead of the trigger. In a bullpup, they move behind it. The same barrel can fit inside a shorter overall weapon. But compactness is free only in a drawing. In service, that saved length reappears as a longer trigger linkage, a different balance, restricted ejection, unfamiliar controls, and a new burden for training and maintenance. Every major bullpup would renegotiate that same bargain. The Victorian experiments proved the geometry before they proved the need. A London gunsmith built a heavy bench rest rifle in the layout around 1860. William Curtis patented a repeating version a few years later. Neither was a military success, but both showed that the idea was technically possible. What they lacked was a problem urgent enough to justify changing everything around the shooter. That timing is revealing. 19th-century armies were not building doctrine around vehicles, electronics, or compact urban weapons. Their rifles were expected to reach across open ground, survive simple maintenance, and fit established drill. A shorter receiver offered little institutional value if it demanded unfamiliar loading, sighting, or balance. The invention arrived before the procurement case. James Thorneycroft found that problem after the Second Boer War. British mounted troops had learned how awkward a long rifle could become on horseback. His compact .303 design kept roughly the barrel length of the Lee Enfield while cutting the overall package. On paper, it seemed to be the obvious answer. Trials in the early 1900s exposed the distance between a brilliant measurement and a serviceable weapon. Refinement continued, but the Army chose the more conventional short-magazine Lee Enfield. The first military bullpup lesson was already clear: being shorter was not enough to displace a system that soldiers and factories already understood. French officer Armand Frédéric Faucon pushed the idea farther. His balance rifle placed much of the mass over the shoulder. Testers reportedly noticed less fatigue during extended trials. That was a real advantage, not a novelty. Yet the remote trigger connection was difficult, and the unusual form complicated evaluation. The design revealed the paradox that would follow bullpups for a century: moving weight rearward could improve balance while the linkage required to reach the action made the human interface worse. Faucon's work also anticipated a pattern in later prototypes: designers could fix one complaint by making another part of the weapon stranger. Better balance might require an unconventional sight line. A shorter body might place access panels where armorers did not expect them. The bullpup did not remove engineering choices, it concentrated them. The first bullpup adopted for combat emerged from a Czech design taken over after the German occupation of Czechoslovakia. The PzB M.SS.41 was a compact anti-tank rifle produced in very small numbers. It shortened an already enormous weapon, but the battlefield problem changed faster than the design could mature. By the time heavier armor made its cartridge ineffective, the first combat bullpup had become a compact answer to a disappearing question. The FG-42 is sometimes pulled into the same family, although its action sits closer to the trigger than a true bullpup. That disagreement matters because the category has always had fuzzy edges. The PzB also exposed another pattern: bullpups were often selected when designers had to package an unusually long mechanism or barrel. That made the saved length dramatic, but it also tied the rifle to a narrow roll. When the roll changed, there was little reason to preserve the rest of the system. The layout had done exactly what it promised and still could not save the program. After 1945, the concept became a playground for major designers. German Korobov entered the TKB for 08 in Soviet trials, then returned with the radically compact TKB 022 family. John Garand produced the T-31 in the United States. These prototypes showed how much machinery could be compressed into a short shell. They also showed the price, heat, fouling, manufacturing difficulty, and mechanisms too complicated for mass service. The post-war graveyard was full of rifles that looked more modern than the institutions asked to support them. Korobov's later work was especially dramatic. The TKB 022 family compressed a full rifle into a body little longer than many modern personal defense weapons, using extensive polymer and an unusual forward ejection path. It was a remarkable demonstration, but a demonstration is not a supply chain. The Soviet system chose the more conventional Kalashnikov lineage, where production knowledge, field familiarity, and evolutionary upgrades carried more weight than the shortest possible silhouette. Garand's T-31 reached a similar dead end from another direction. Its experimental gas system accumulated fouling and never became a practical service candidate. Then Britain came closer than anyone expected. The EM2 combined a bullpup layout, an optical sight, and an intermediate cartridge at a moment when most service rifles still looked rooted in the previous war. In 1951, Britain adopted it as Rifle No. 9 Mark I. For a brief moment, a national army had accepted the entire package, not just the shape. Its defeat did not come from geometry alone. NATO ammunition standardization moved toward a more powerful common cartridge, and Britain reversed course. The EM2 became one of the great alternate paths of small arms history, a rifle judged promising by its users, yet stranded when alliance policy changed the ammunition beneath it. This is where the bullpup story stops being a catalogue of mechanisms and becomes a story of systems. A rifle can be technically convincing and still lose to logistics, alliances, and timing. The timing made the reversal especially consequential. Britain had paired the EM2 with the smaller .280 British cartridge, treating rifle and ammunition as one modern system. Standardizing on the larger 7.62 NATO round did not merely require a new chamber. It changed weight, controllability, weapon dimensions, and alliance supply. The rifle that had been optimized around one compromise no longer fit the compromise chosen for the alliance. A procurement decision made above the rifle effectively erased the rifle. Austria finally produced the durable success. Adopted in 1977, the Steyr AUG looked futuristic because nearly every visible choice belonged to the same concept: polymer construction, an integrated optic, modular components, and a compact silhouette. It did not merely shorten a conventional rifle. It created a coherent service package around the bullpup layout. Austria kept it. Australia developed the F88 family from it. Several other countries followed. The AUG proved that a bullpup could work for decades when the weapon, training, manufacture, and upgrade path were designed together. Its longevity is more revealing than its appearance. The original integrated optic could have trapped the rifle in the 1970s, yet later variants accepted new sighting systems and accessories. Australian versions changed barrels, rails, materials, and manufacturing while retaining the central layout. That is what successful standard equipment usually looks like, not a perfect first model, but a platform with enough institutional support to keep changing after the first designers are gone. France followed with the FAMAS F1. Its distinctive shape concealed an equally distinctive internal system. It served across several decades, but its long-term fate exposed a dependency that procurement brochures rarely celebrate. The rifle had been designed around a particular ammunition and magazine ecosystem. As that ecosystem changed, keeping the weapon reliable and economical became harder. France began replacing it with the conventional 416 Hong Kong dollars in 2017. The FAMAS did not simply become old. The industrial world built around it disappeared. That distinction matters. A weapon may remain mechanically functional while becoming strategically expensive. Proprietary magazines, ammunition assumptions, tooling, and spare parts can turn a national icon into an isolated island. France's replacement decision therefore says as much about standardization and life cycle cost as it does about the shape of the rifle. Britain's SA80 family delivered the harshest version of the same lesson. The original L85A1 entered service with serious reliability and quality problems. A major remediation program led by Heckler & Koch produced the improved A2, and later upgrades kept the family relevant. It is important not to collapse those versions into one verdict. The A1 damaged the rifle's reputation. The A2 and A3 demonstrated how much engineering and money could recover a troubled system. Britain obtained a capable later weapon, but only after paying twice, first for adoption, then for rescue. The SA80 also shows why a famous failure can distort the larger argument. Its early defects were not proof that every bullpup was doomed. Austria's August already contradicted that. But the rescue program proved that layout cannot protect a project from weak manufacture, rushed qualification, or fragmented responsibility. The rifle on the parade ground was the visible end of a much larger production decision. By this point, the recurring trade-offs were no longer mysterious. A remote trigger could feel less direct. The ejection port and action sat close to the face. Controls and magazine placement could complicate a training system built around conventional rifles. Some designs solved left side use elegantly, others required configuration changes or never solved it at all. None of these issues made the layout unusable. Together, however, they reduced the advantage of being shorter, especially as conventional rifles gained collapsible stocks, better optics, and modular accessories. Ronnie Barrett tested the geometry at its most extreme with the M82A2. He moved the controls of the long M82 platform forward to create a shoulderable bullpup variant. Only a handful were sold. The concept failed commercially, but it clarified the layout's strongest remaining case: when barrel length is non-negotiable and total length is the dominant constraint, moving the action rearward can still be uniquely valuable. The same logic later appeared in other large caliber designs, even when Barrett's particular experiment did not survive. This is why large caliber and specialist rifles appear disproportionately often in bullpup form. Their long barrels create a packaging problem that an adjustable stock cannot fully solve. The trade-offs that irritate a general service program may become acceptable when compactness has a much higher value. In other words, the bullpup becomes stronger as the requirement becomes narrower. During the 1990s and 2000s, the bullpup went global. China fielded the QBZ N95 in enormous numbers, making it one of the most produced examples of the type. Israel developed the Tavor and later the X95. Belgium's FNF 2000 used forward ejection to address one of the layout's oldest limitations. Singapore produced the SAR-21, Croatia the VHS family, and several countries built compact conversions or original designs of their own. Each country emphasized a different answer. China paired the QBZ N95 with a domestic cartridge and a national family of weapons. Israel treated compactness as useful for a mechanized force and continued refining the concept into the smaller X95. FN engineered a forward ejection channel so the rifle did not have to choose a permanent side, but the solution added its own complexity. Singapore emphasized an integrated, controlled package. Croatia kept evolving its VHS design rather than freezing the first version. There was no single bullpup formula, only different decisions about which cost was acceptable. The numbers made the bullpup look victorious. The replacement choices complicated that verdict. China moved toward the conventional QBZ 191. France chose the 416 Hong Kong dollars. Britain's future rifle work has centered on conventional candidates. Israel has evaluated conventional alternatives even while the Tavor family remains influential. These decisions do not prove that every bullpup failed. They show that the industry around conventional rifles became extraordinarily adaptable. Once adjustable stocks, ambidextrous controls, common magazines, rails, and mature supply chains were available, armies could recover much of the compactness without accepting an entirely different architecture. That competitive change is easy to miss. Early bullpups were compared with rifles whose fixed wooden stocks consumed considerable length. Modern conventional designs no longer present the same target. Stocks collapse or fold, controls can be mirrored, upper receivers accept common optics, and accessories move between families. The bullpup kept its geometric advantage, but the practical distance between the two layouts shrank. A revolution is harder to justify when the incumbent improves every decade. Meanwhile, the smaller list of continuing successes prevents an easy obituary. Austria still operates the August. Australia's evolved F88 family shows that a bullpup can absorb new optics, rails, electronics, and manufacturing changes when the upgrade path is funded. Croatia continues with the VHS-2. These examples share something more important than their shape: they are supported as living systems instead of preserved as isolated mechanisms. Ukraine's Malyuk shows why the idea has not vanished. Developed from an AK-based system and introduced into service in the 2010s, it places familiar internal components inside a bullpup arrangement. As of 2026, it remains part of the modern history of the conflict, but its larger significance is conceptual. Countries can still choose the layout when compactness and an existing mechanical base align. The bullpup is not extinct. It has become conditional. Conversions such as the Malyuk also reverse the usual development path. Instead of designing a new mechanism and a new layout together, they preserve a known mechanical family while changing the package around it. That can reduce some industrial risk, but it does not erase questions about controls, balance, maintenance access, or long-term standardization. Familiar internals are only one part of a service rifle. That is the real verdict after more than 160 years. The bullpup solved a geometric problem: it preserved useful barrel length while shortening the weapon. What it could not guarantee was a better trigger, easier adaptation, cheaper maintenance, compatible ammunition, or institutional patience. The best examples, especially the August and its Australian relatives, succeeded because their surrounding systems made the geometry worthwhile. The worst examples treated compactness as if it could compensate for everything else. So the future did not exactly fail. It narrowed. Bullpups remain brilliant where length dominates the decision. Everywhere else, the conventional rifle learned enough new tricks to make the revolution optional. Which design made the strongest case, and which one proved the idea had gone too far? Tell us below. If you want more histories where engineering meets procurement, subscribe for the next one.